ladies and gentlemen. Welcome to our physics revision class, and in this class we're just going to look at physics 1015, and this was written during the 2023 final examination. And for today's class, I'm focusing on question 4. So please make sure that you check up the question paper and make sure that you are able to follow up. So if you look at these questions, all these questions, most of them are coming from the issue of Newton laws of motion. Most of them are coming from Newton laws of motion and many other stuffs. So the question is, the principle of conservation of energy tells us that we can never lose or gain any energy out of nowhere. Apply this principle and assume that no energy is lost through friction or air resistance. So this point was just there to confuse a lot of people. A lot of students, they got confused on this statement, but one thing that you need to understand is that we just have the main guys, which are the questions. A large jumbo jet airplane shown below is cruising at a speed of 900 km per hour and has a flight of 400 tons. What is its kinetic energy in gigajoules? So we'll start with the first question. So I'll write my solution there. And I'll work on this question very easy and straightforward. So this question is involving much of changing the units. So what we are going to say, we are going to collect our data. So the first information we have is the velocity, which is 900 km per hour. So we are going to convert this to meters per second, because these are the SI units. So one thing we need to understand is that if we have a 1 kilometer per hour, so if we have a 1 kilometer per hour, we need to know how many meters per second do we have. So 1 kilometer per hour, if you check up this 1 kilometer, according to the information, when we change 1 kilometer, it's going to give us 1000 meters. Okay, 1000 meters. And then for hours, you can simply say 60 seconds times 60 minutes, and this will simply give us 1000 meters over 3600 second, and this will give us somewhere like 0.2778 when you round it off. So with this information that we have, we can simply say 1 kilometer per hour is simply equal to 0.2778 meters per second. So this is the part which you are supposed to show. Then how many kilometers have we been given? We have been given 900 kilometers per hour, and we need to convert it to meters per second, which we don't know, and we can make it to be our x. So once you change these values, when we change these values, we're just simply going to say 900 times 0.2778. So this is simply giving us something like 250 meters per second. 250 meters per second. So this is the speed at which this guy was moving at, 250 meters per second. So the guy here was just moving at 250 meters per second. So with this information, therefore, we know that our velocity is simply equal to 250 meters per second. Now we can get our other information. Our other information is for the mass, which is 400 tons. So for the mass, we are simply going to say mass is simply equal to the one which we have, which is 400 tons. So 400 tons. Okay. So if you want to change tons to what? Tons to kg. Remember the SI units need to be in kg. So what we are going to say is 1000 kg is simply equal to 1000 kg is simply equal to 1 ton. So 1 ton is simply equal to 1000 kg. Or you can simply say 1 kg is simply equal to 0.001 ton. Okay, so with that information, you can now say if we have given the amount of kg which we are looking for, so you just put this one as your x, and then this side you're going to put the tons which you have been given, which is 400 tons. Yeah, 400 tons. So from there you can simply cross multiply. And x will simply be equal to 400 tons over 0.001. So when you divide throughout, when you divide 400 tons, when you divide 400 tons divide by 0.001, which is going to give you 400,000 kg. So you have 400,000 kg. So this is the mass which we were given, 400,000 kg. So with this information, we have the mass, we also have the velocity. Our next target is now to use the formula for kinetic energy to find now the kinetic energy which was given. So for that, we are going to say Ke, which is kinetic energy, is equal to 1/2 mv squared. Okay, so from there you can simply say Ke is simply equal to 1/2 times the mass, which is 400,000 kg times 250 squared, which is our velocity. So Ke is simply equal to the same 400,000 times 0.5 times 0.5, which is simply what we have, which is 200,000. So this times that, which is simply 200,000 times 250 squared. So Ke is simply equal to 250 squared 250 squared, which is going to give you something like 1.2 times times 10 to the power 10. Yeah, it's a big number, so I've expressed it in significant figures. So that's the number you are receiving when you press on your calculator. So with this information, this is joule. Remember, what we have found here is joule, so we can now convert the joules to gigajoules. So we have been given the gigajoules there. So you need to understand that 1 gigajoule is simply equal to 1,000,000,000 joule. And then what we have there is x is simply equal to 1.2 times 10 to the power 10. So when you cross multiply, x will simply be equal to 1.2 times 10 to the power 10 over 1,000,000,000,000. So 9 zeros. So x will simply be equal to, so the same answer which you had on your calculator, you're going to divide it throughout by that guy, which is to the power 9. So what you're going to have is just simply 12.5 gigajoules. So 12.5 gigajoules was the final answer for this particular question. So this is how easily this question was. So this question was coming from work, energy and power. It's coming from the topic work, energy and the power, but the only thing which is there is that there is an inclusion of unity conversion. There is an inclusion of unity conversion, which you guys are supposed to make sure that you know. With this information, ladies and gentlemen, do we have any questions so far? Any question? Do we have any question? Those with questions, feel free to ask. Evaristo, do you have a question?
No, sir, I don't. Thank you so much.
All right, you're welcome. So let's quickly move on. Okay, let's quickly move on and look at the next question. Please guys, if we are solving, in case you have a question after the class, feel free to inbox me. I'm here to help you and I'm here to guide you so that you guys can have a successful academic year. So how fast does a stone hit the ground if it drops from a building of height 830 meter above the ground? So guys, this is coming from the Newton laws. This is coming from the Newton laws. Very easy question. I wonder why it was even 6 marks. So here you're going to collect the data. What we have is the building. So if this is the building, remember to write something like a sketch. Normally these marks they also cater for the diagram, so make sure that you do such sketches. So the building is having the height. So this height is the one which is 830 meters. So this is 830 meters. So 830 meters. Okay, so that's the guy. Then we have the stone which has been dropped. So this stone has been dropped like that. So if this is your stone there, and then remember there is acceleration due to gravity, which is the 9.81. I'm going to use the one which was given there. Then from there, what else have I been given? Nothing else apart from that. Okay, so if I've been given that, it's this stone has been thrown from the rest, isn't it? So from there, I can simply say the velocity is simply equal to 0, the initial velocity. So with this data which I have, I can easily come up with a equation which is having everything, and this equation is S is equal to V0t plus C half AT squared, So S is the height, and then the V, it is simply 0, so times the time there. Remember, we are looking for how fast, so how fast simply mean what? Time. Okay, how fast simply mean time. So from there it will be plus 9.81 times 0.5. I've just changed half to 0.5. So from that information which I have indicated there, I can simply replace h with what is supposed to be there, which is 830 meters, and this will be equal to 0 times t, it's simply 0, and then 9.81 divided by 2, or times 0.5, it's going to give you 4.905 t squared. So from there, you divide throughout by 4.905, you divide throughout by 4.905. So when you divide throughout, you're going to have t squared is simply equal to 830 divided by 4.905. It's simply giving you 169.215,086, and then some other numbers there. So from there, you can introduce a square root. You introduce a square root. Since it's distance, we'll consider the positive guy. So t is simply equal to, we are going to do the square root of what we have, which is 169.215086. That's what we have. So here to give us something like 13.008269931,086 seconds. So I'll round it off to two decimal number, to two significant figures. So this will be 13 seconds. So the answer for this particular question was the 13 seconds. It was a very easy question, and you just have to be careful as you present your work, because these formulas and also the diagram, they carry marks. You might know how to solve, but if you haven't illustrated the diagram, which is part of your solution, then you might lose some marks. So before I move on, you guys are free to ask questions. Yes, Killian.
Right, so I've analyzed the question
I can't get you.
Isn't the question saying velocity? Say, can you get me?
Yes.
Yes, I was asking, isn't the question asking for the velocity since it's saying how fast? Maybe if it said how long would use time. Since it says how fast, isn't it requesting for the velocity?
Oh, yeah. Okay. In that case, thank you for that part. But I also emphasize for you to be able to know the time. So how fast, that can simply mean the what, the speed. So in that case, it's very easy for you to solve it. So guys, let's make sure that we understand the correction there. So you can simply use v squared plus, oh sorry, not v squared plus, you can simply use the last formula, which is having what we have been given. So this will be v squared is equal to u squared, or initial, and then plus c 2, and then as plus 2as. So from there you can select the downward as your downward as your positive. So v squared will simply be equal to 0 squared plus c, you can say 2 times 9.8, and then times the distance, which is 830. Okay, so from there v squared will simply be equal to v squared will simply be equal to 2 times 9.8, 2 times 9.8 times 9.81 times 830. Okay, so this is somehow giving us a value 16,000 to 16,284 284.6. If you introduce the square root, so v will simply be equal to the square root of what we have. So 16,284.6, and this is just giving you 127.6111, so 128 meters per second. So this was the answer. So for the how fast was velocity, the final velocity, yeah, thank you for our friends who did English. And then for the time, it's just like this, just in case this question was how long, you normally utilize this same formula. Of course, you find the answers the way they are. Okay, let's move on and look at C. I'll write my solution. So for C, it's an easy question. How high does water from a fountain rise if it is injected vertically upward? So if the water is moving vertically upward like that, and the speed is 3.5 meters per second, we know acceleration due to gravity will simply be equal to negative 9.81 meters per second. So for vectors, it depends with the question. You can treat A to be positive or A to be negative, but it depends with how the question is set. Yeah. If you look at projectile motion, when going down, we were treating A to be positive. It was negative when going down, but again, when going up, we are treating A to be negative. The reason is it depends with how you are treating the other values. Okay, so in this case you still use, since they are saying how high, okay, you use the same formula, which is we know v final there. V final will simply be equal to 0, and then this will be our v initial, and we don't have time, we don't have distance, which is s there. We don't know s, what's value of s is. So we use the same formula, vf squared is equal to v0 squared d plus c 2as. So after that, this is 0 squared is equal to initial, which is 13.5 squared d minus 2 times 9.81, and then the distance, which is just s. After we do that, we can work on what 13.5 squared is, which is just 13.5 times 13.5 is simply going to give us 0 is equal to 182.25 minus, then we can say 2 times 9.81, 2 times 9.81 is giving us 19.62 s. So this can go to the other side and it will be negative, then you multiply throughout by negative. So 182.25, and then this one will be negative 19.62 second over negative 19.62 over negative 19.62. so this guy and that guy will go, so s will be equal to what we have, which is 182.25 divided by 19.62. so this is simply giving us something like 9.2888. so 28899 meters, and when rounded off, this will simply be 9.3 meters, like that. So this is how the final answer was. So this is how easily you can solve these questions. So these questions, the only question which I think might have been tricky, it is this one, because of the use of unit conversion. So this was the only tricky question, but anyone can get that one correct and that one correct. That's why when you are asked to choose which questions, you have to know which one can you get correct and which one can you not get correct. So ladies and gentlemen, this marks the end of our class, but for those with questions after the class, you are free to WhatsApp me on those lines. But for those who have questions right now, you are free to WhatsApp me right now.